Hello, welcome to the Thermophysics Laboratory at Imperial College London. My name's Martin Trussler, and in this short video I'm going to show you a laboratory distillation column in action. Here's the apparatus, and let's look at the individual parts in turn. At the bottom we have a reboiler, consisting of a glass vessel sitting on an electric heating mantle. In this experiment we're simply boiling pure water. At the front you can see a temperature sensor probe inserted into the reboiler, and towards the right you can see a small diameter translucent tube which connects the reboiler to one port of a differential pressure sensor. On top of the reboiler we have a glass sieve plate column with an internal diameter of about 25 millimeters. The column contains 10 small sieve plates and is enclosed in a silvered vacuum jacket for insulation. Just above the vacuum jacket you can see a second temperature sensor inserted in the path of the vapour passing up from the top of the column. Above the column we have a water-cooled condenser which condenses all of the vapour and allows some or all of it to be returned to the column as reflux. There's also a second small diameter tube leading from the top of the condenser to the other port of our differential pressure sensor. Here we see the condenser in more detail. It's water-cooled. The chilled water flows first through a coil in the centre of the condenser tube and then passes through an external jacket before returning to the chiller. You can see the vapour condensing on the chilled walls and running back down towards the column. To the left is the reflux valve, manual on this apparatus. At the moment the valve is closed so that all of the condensate returns to the column as reflux. If we open the valve partially, we can draw off some of the condensate as a distillate product and collect it in a flask below. Here we're looking down into the column through a gap in the silvering. You can see the liquid on each of the plates with the vapour bubbling through. These still images taken before we started the column up allow a clearer view of the interior. To the left we can see 3 of the plates inside the column. In the centre, an enlargement of one of them, where the perforations in the plate, the weir and the downcomer from the plate above are clearly visible. On the right we're looking down into the top of the column and you can clearly see the perforations on the top plate. Our column is instrumented, and here you can see the readout units. The top one reads the pressure difference between the reboiler and the condenser in units of kilopascals. It's fluctuating slightly as the liquid boils. Below that, the display labelled T1 reads the temperature in the reboiler, while the display labelled T2 reads the temperature of the vapour leaving the top of the column. We can see that T2 is the equilibrium temperature expected when we boil water at ambient pressure. On the other hand, the temperature in the reboiler, T1, shows evidence of a little bit of superheating. Now you've seen the components of our laboratory distillation column. You've seen the flows of vapour and liquid inside the column itself, and the readings of our temperature sensors and our differential pressure sensor. Of course, with just pure water boiling in the column, it's not doing anything very useful. But in the next video, I'll show you the column in action again, this time separating a mixture of water and methanol. For now, that's the end of this short video, so thank you for watching.